Good morning, friends. Myself Shankar Bhanase. Today we are going to see examples on the parametric curve. In previous lecture, we have solved one example. Now, in this lecture, we are going to solve one more example of the parametric curve, that is of cycloid. Okay, let's start. Consider. Uh, let's consider the next problem, next example. Trace the curve x is equal to a into t minus sin t and y is equal to a into 1 minus cos t. That is, this is the another type of cycloid again. That is a rolling cycle without sliding. Okay, we know that how to trace the parametric curve by using the properties symmetry, origin, limits of xy and tangents. That is, in this way. Suppose the first one is symmetry. And what is the symmetry? If we replace t by minus t, if x remains unchanged, symmetric about x-axis, y remains unchanged, symmetric about y-axis. Always, if it is cycloid, then y remains unchanged because y contains the even function cos t. Cos of minus t, again cos t, unchanged. Therefore, symmetric about y-axis. Next, we'll consider origin. Next, limits, and next tangent. And we know the value of a tangent, that is dy by dx, and we can find it for the parametric functions as dy by dt upon dx upon dt. After finding the derivatives, if we take the ratio and after simplification, we get cot of t by 2. Okay, next, now go for the table. The limits and the origin we will get from the table only. At the time of theory, I was explaining that thing. Okay, next, in the table, first row will be t. In first row, first element t, next x, that is the value a into t minus sin t, second y, and next xy coordinate and value of dy by dx at that particular value t. Put the values t now, fix the values 0 to 2 pi, 0 pi by 2 pi, 3 pi by 2 and 2 pi. Next, at t is equal to 0, x gives the value 0 because sine 0 is 0. When we put pi by 2, we get sine pi by 2 1, that is a into pi by 2 minus 1. Next, if we put pi, we know that sine pi is 0, therefore it becomes a pi. Similarly, a into 3 pi by 2 plus 1. Next, 2a pi at 2 pi. Okay, now let's go for y. Try to find out the values of y. If you put 0, cos 0 is equal to 1 and 1 minus 1, 0. Therefore, value is 0. If you put pi by 2, it is a because cos pi by 2 is 0. Next, if you put pi minus 1 plus 1, it is 2. 2 into a, 2a. Similarly, a and 0. In this way, we'll get the points as 0, 0, first point, second point, third point, a pi 2a, third, fourth point, and fifth point 2a pi 0. Okay. At the similarly, at the value of t, find the value of dy by dx. It is cos 0 is equal to infinity. Next, it is 1. It is 0. Cos pi by 2, obviously. Next, minus infinity. And the last 2 pi, it is cos pi is equal to infinity. In this way, we have completed our table. Now just write down whether the curve has origin or not. Clearly, by observation, the first point at t is equal to 0, we are getting 0, 0. Therefore, curve has a origin. Next, limits. This point is always a fixed, like symmetry for a cycloid. Symmetry for cycloid always symmetric about y-axis. Similarly, limits for x and y are same. Limits for x minus infinity to plus infinity and for y 0 to 2a. Okay, and we have got three tangents from the point 0 0, a pi to a and 2a pi 0. From 0 and 2 pi, 0, 2a pi and 0 and 0 0 tangent is parallel to y-axis, and the middle one, the third point, from that point tangent is parallel to x-axis because dy by dx is equal to 0. Okay, now let's try to trace or draw the curve. Let's draw the curve now. This is x-axis, y-axis. Consider origin 0 0. Okay, our first point is 0 0, therefore this is my first point. We have to trace only 3 points, 3 finite points: first, third and fifth. First, third and fifth. Okay, this is a pi and 2a. Mark this point. Next, it is 2a pi 0, which is on x-axis. Okay, after that draw the tangents. 0 0 and 2a pi 0, dy by dx is infinity, therefore tangent will be parallel to y-axis. From 0 0, y-axis itself a tangent, and next this is from 0 0, and this is from a pi to a parallel to x-axis, and this is from parallel to y-axis. These are our tangents. Now as the limits for y is up to 0 to 2a, that means curve will be like this way. These are our tangents. Curve will be like this way because upper side will not exist because limit of y is up to 2a. Similarly, just extend the curve on both the sides because limit of x is minus infinity to plus infinity continuously. This is our cycloid, second type of the cycloid curve. Okay, let me explain again. It is a parametric curve because x and y are given in terms of t, where t is our parameter. Symmetry we have found with replacing t by minus t, and already I have told you a cycloid is always symmetric about y-axis because y contains the function of cos, and cos is a even function, therefore it is symmetric about y-axis. Always cycloid symmetric about y-axis. Limits of x and y are same always for the cycloid. The origin will change as per the table and as per the values we are getting in the table, and tangent every time we have to find in this way only, dy by dx, taking ratio and find the value of dy by dx after simplification. Next, we know the table. For the table, just we have to the values of t are fixed, that is 0, pi by 2, pi, 3 pi by 2, 2 pi. Always we have to consider these values only. Next, x, y, put the values of these, put these values of t in x, y and get the values of x and y. In this way we'll get our point x, y, and similarly we can find the value of dy by dx by putting the values of t in the given values of dy by dx. Okay, remember always at the time of tracing we have to consider three finite points only: first, third and fifth. Always we have to consider three finite points: first, third and fifth point. And we have to consider tangent at only infinity and 0. If dy by dx get infinity, that means tangent is parallel to y-axis from that point, and if it is 0, tangent is parallel to x-axis. First we have flowed the points, after that we have drawn the tangents from that point, whether it is parallel to x-axis or parallel to y-axis. After that, considering the limit of y, we have drawn the shape of the curve, that is a rolling a cycle without sliding. Okay, this is our cycloid. Remaining two cases are there, we will study in the next lecture. Okay, thank you.